Good evening, guys. Today we are back with another problem, and today's problem is the closest three-sum problem. Okay, so we have already solved two-sum problems in LEED code, and which is a very basic problem. But today's problem is about a three-sum problem. So here the only difference is you will be given a three pair of values, and it has to match to a target value, say 2, and then you have to give the output based on the target value, and so on. So let me just check. There is only one triplet present in the array where elements are 7 minus 1. Okay, so let me just check the elements. 7, 8, okay, which is 1, and 1 plus 1 is 2, and our target is 2, so it is matching the target value. So we have to find such elements, and we have to even return the maximum sum. So maximum sum, if you see the question, find such that the sum is closest to the target, return the sum. If there are multiple solutions, return the maximum one. Okay, so let us just quickly dive into the question before going any further. So what you can see is in the solution we will have a three-sum closest function. We will be passing an array, and then there is a target value. In the difference is nothing but the difference between the target and the sum obtained. So we are storing it to the maximum possible integer value by indifference, and the answer also we are taking as the maximum possible integer value. Then we are storing the array in a sorted manner. Now we are starting the array. Say for example, this is our elements. Okay, so let me just write the elements 5, 2, 7, 5. 5, 2, 7, 5. Our target is equals to 13. Okay, so this is our target. There is one triplet with sum equals to 12, and the other with sum equals to 14. Okay, triplets are 5, 2, 5 and 2, 7, 5. So let's check the triplets. 5, 2, 5, which is 12, and 5, 7, 5 and 2, 7, 5. 2, 7, 5, which is equals to 14. But it's an interesting case. If you see, we have to find 13. So which value we are supposed to take? Okay, so we are obviously going to take the maximum value, which is closest to the target. So if our target lies over here, we are going to take this maximum value, which is closest to our target. So how we are going to achieve this? That is, you can see 12 plus 5, and if you see all these things, they add up to a particular sum. We have to return the maximum sum, which is closest to the target. So first, once we get the array, we are going to sort the array. So if we sort the array will become 2, 5, 5, 7. Okay. Now we are going to use a two-pointer technique. Two-pointer. Okay. We are going to use a two-pointer technique. What is so special about it? First, we are going to iterate the array from I equals to 0. So if I just 0, 1, 2 and 3, these are the indexes of the array. So what I can get is, we are going to start with I equals to 0, which is over here. And we are going to, in our sum value, and we will have a start and an end. So in the two-pointer technique, we will have a start equals to 0 and end equals to array of length minus 1, which is over here 0, 1, 2, 3. Array of, say for example, length minus 1. If the user gives the length of the array as n equals to array of length, which is nothing but 3, so 2. Okay, and what else we are getting? S equals to I plus 1. So our start is not 0. Our start is I plus 1, which is 1. Okay, and what else we have? We have an array of Si. So in the first test case, it is iterating like this, that I is 0. Okay, S equals to I plus 1. So if sum equals to, I know sum and start is less than end. Okay, this is start, this is length. So just you can write it over here. This is start and this is end. So if the sum is equals to, we are going to add 3 values. Since it's a 3-sum problem, we are going to add 3 values. So first is array of I. So what is array of I? Array of I is nothing but 0. So array of I is 2. Okay, I will just use my red pen over here. Array of I is 2. Array of I is 2. Okay. Next what we have, array of S, which is 5. Okay. And next what we have, array of E. Array of E is, which is 2. So 2, 5 and 5. So our output, if you see, we are getting an output as 12, which is the first test case. Now if my sum is equals to target, is my sum really equals to the target? My target is over here. If I see my sum, if I see my target is 13. So which test case is going to pass? Sum is lesser than target, then we are going to, sorry, I just went offline. Yeah. If my sum is equals to target, then I'm going to return the sum. So if I'm returning the sum, what you can see is my sum is equals to target, I can return the sum. So no, my sum is not equals to target, so I'm going to move the pointer up. So if I move the pointer up, my S value will now shift to I plus plus. It was already 1, it will shift to over here. So my S will become 5. Okay, now my S is 5. My S equals to 5. What else do I have? If mat dot absolute value of sum, which is 5 minus of target. So what is minus of target? 5 minus of target. If my target is 13, okay, so if my absolute value, if I take an absolute value of this value, what I'm going to get is 8. Okay, is 8 lesser than equals to difference? So where is the difference? Difference is equals to integer dot max value. Yes. Else if I'm going to store my answer equals to sum. So in my answer, if I store my answer, it will become my sum, which was nothing but sum was 13. I guess no, the sum was 12. Okay. Similarly, in answer equals to sum, and we are going to return the sum. No. If in this case, when we are checking that if our max value is somewhere closer to the sum minus target equals to difference, what we can see is we are going to take the maximum of the answer and sum. So in our next iteration, when the pointer moves further, we are going to reach to a state where we will have the values 2, 7 and 5. So we will be getting a pointer as 14. Okay, so obviously if 14 is stored in the list and 12 is also stored in the list. So if 12 and 14 both are stored, we are going to take the maximum value and return this. So this is the three-sum problem which we are facing in the problem statement, and we are going to return the answer. Okay, answer is nothing but the it is going to store the maximum of the two sums. So it's the maximum of the two sums which we are getting, and we are going to return the answer. So let's just execute the code over here. We've done the same code. If you want, you can just use the code from here. I'm going to submit the code. So hopefully this is a not so very difficult problem, and it's going to pass all the test cases. Yeah. So I guess you guys like the solution, and we are looking for our next video.